Hi, my name's Jordan Marshall and I'm Special Projects Editor at Building Magazine. I'm so delighted to have you all join us today for this session. It's going to be a really great one. It's all about prefabrication and efficiency in the construction sector. We've got some great speakers for you today. We've got Ben Warbank, BIM Strategy and Partnerships Manager EMEA at Trimble Viewpoint, Matt Benyon, Chief Executive Officer at Reds 10, and Gary Cowan, Head of Digital Construction at Kane Group. We're going to cover a lot of ground, but we definitely want you guys to all get involved. So please send through your questions at any stage. The way today's session is going to run is each of our speakers is going to give a presentation on their overall views on the topic before we jump into a group discussion and Q&A. But please do send through those questions at any time as they occur to you, and we'll try and cover off as many of them as we can. A couple of other housekeeping matters from me before we get stuck into things. Yes, this session will be available on demand. We get that through all the time. It will be available on demand for free via the same link you've just joined by now within about half an hour of the end of the session. So please feel free to disseminate that link with your connections who you think will be interested, rewatch to catch up on things you might have missed, or do anything else you like to watch it again. It will be there for 12 months. So I think that's probably enough for me to kick things off. So first of all, we're going to be hearing from Ben. So Ben, I'll hand over to you.
Can everybody see my screen?
That's perfect.
Okay, great. Okay, so I'm going to just apologise first of all. You can probably all hear in my voice, I have an absolutely stinking cold. So if I start to cough or wheeze, my apologies in advance. So actually, Matt and Gary are, on the coalface doing all this stuff for real. And I think my role here, coming from the software industry and as an architect, is to really kind of set the picture. So in the next 10 minutes, that's what I'm going to try and do. So I'm going to look at why only now. I'm going to try and frame what I think the challenge is, both more generally and from government. I'll have a look at what some of the potential answers are, what some of the potential advantages are of prefabrication, look at the current drivers, and give, I guess, inevitably, a technology provider's perspective on this. We've sponsored this talk, and one of the reasons that we thought prefabrication would be a really good topic is that we are more and more with all our customers seeing that this is becoming a larger part of the industry at the moment. So look, why now? Actually, so here we've got a photo from the late 40s of some early clasp school building schemes in Hertfordshire. And this was about, again, I think, we can look at whether the challenges of the financial situation, i.e. post-war with huge, government debt, whether some of those challenges are similar now. And this was, can we make building at volume cheaper by adopting some prefabrication methodology? And obviously it wasn't just that, it was also some of the actually highly loved prefabs that were, designed to help the housing shortage post-war. And, whilst very clearly those were all buildings that wouldn't satisfy today's standards in terms of, sustainability or air leakage and all of those things which are major issues now, this has been going on for a while. So it becomes quite interesting to me, throughout my now appallingly long career, I've always heard about this as a topic. So why am I now seeing so much more adoption of prefabrication again? And, why hasn't it been adopted much sooner? Because you would expect that it would have been. And I think part of the reason obviously was, some of these early, so this is Ronan Point, which was a prefabricated structural scheme from the 60s for doing housing, which had a huge and very disastrous, it was, if you like, the Grenfell of its time, killing many people. You know, so I think that there are examples like this which perhaps set things back a bit. But we've been tasked, you know, why are we seeing this so much more now? So if we look back to 2013, the industry as a whole was tasked under the Construction 2025 paper, and so we're now only a couple of years away from 2025, with, in terms of the 2008 benchmark, driving down to lower costs of 33%, faster delivery, lower emissions, and improvement in exports. And you know, I would argue quite strongly that you know, if you think about the role that prefabrication might play, that it can begin to address how we get there. So this might be achieved obviously through the modern methods of construction that we've all heard about. More factory prefabrication, again, that you can see how that might help with exports. More site assembly rather than building. I think BIM, you know, my particular interest is absolutely linked with this, the move to a digitalized industry. So you can see, for instance, in terms of that, you know, perhaps with library or family parts being provided by who's doing the prefabrication to architects and the design teams, that this could help again with the efficiency of design and that data that's embedded now and that's going to go through for the whole life management of the asset, that, you know, that can become a much more efficient process through this. So, you know, these whole integrated design and manufacture issues. And really importantly, I would argue strongly, and Gary's going to give a fantastic set of examples shortly, that we should not just think about prefabrication on new build, but certainly for the refurbishment of our existing assets too. So there are plenty of potential advantages, I would say, with this. One obvious one is increased site safety. So assembly will involve less people actually working out on site than has traditionally been the case, and that we should be able through that to increase the safety, though indeed it comes with its own issues. Much more surety of quality, so the challenges, particularly of fire and Part L and so on, can be met. You know, we all know that you know, perhaps with a precast concrete frame and jumbo stud walling, that to meet the fire provisions out on site with on-site construction, we have to be so careful that we are actually building in accordance with those with the standards that we should be. And obviously in a factory environment, this should be easier to achieve. Speed of construction certainly will be addressed by this, because you've obviously got larger elements being assembled on site. That should absolutely be the case. Cost, again, I think we can address that. We saw that in the 40s again with the examples I've already given. You know, the more repeat components that we can get, the more likely it is that you'll get efficiencies of scale and so on. But I'd also argue that at the moment, you know, with the end of freedom of movement and our potential move away from an environment where we can import very skilled, trained labour from other divergent economies to our own, I would argue that there are good reasons why you know, we will be able to address some of these issues within a more factory-based environment. So a better working environment for people. You know, you're not going to be working out on a muddy site and minus zero temperatures. And again, that can also offer the potential for greater investment in a factory-based environment, allowing for more mechanization. So in other words, addressing some of those productivity issues that we hear about so much at the moment for our economy. So I think, you know, all of these have huge potential advantages. And we see, we can see that government, grasped this. So here's the building article from 26th of August this year, announcing the tender, the £10 billion tender for CCS modular, the CCS modular framework. So again, I think part of this is being driven by these measures. And I thought I'd sort of end, well, just before I end actually, just by blowing the trumpet of some fellow architects. So this is Bryden Wood, and I can really strongly recommend anybody reading this article that they've written about the delivery platforms for government assets, and they talk particularly about designing. They say it's not just about removing stuff to factories, actually, getting design being done for the manufacturing process. And I think, and they've done some really fascinating work about identifying, key spans and how you can begin to get structural components to be able to address really most of our needs. So that's me bigging them up, and I can thoroughly recommend that. But actually, so I was really fortunate to go onto site at Hinkley Point a month or two ago, and one of the things I really, big nuclear power station is such a bespoke thing, and I really didn't expect to see much prefabrication. But just to be clear, I kept pointing at these huge buildings on site. Well, what's that? Oh, that's where we prefabricate our reinforcement before it's lifted into site and put in place. That other building there is where we do all the stainless steel work. So, they are seeing the advantages of prefabrication even on a site like this, where you've got these really complex items being developed, through the BIM process. How do you get that to work? So I think that again is really interesting. So I'm going to stop then and hand you over first of all to Gary, then to Matt, to actually talk more about the real challenges of delivery on sites and so on. So thank you very much, and I'll hopefully be able to answer some questions later.
Thanks so much, Ben. As Ben just said, next we're going to be hearing from Gary. So Gary will give you the sharing option, and then you'll be able to share your slides too.
Okay, just let me know when that's there. Perfect. Okay. Well, thank you very much for today's invitation. It's great to be here and chat with everyone today. My presentation today is really just to give an insight into how we at Kane have driven efficiencies using a prefabrication workflow and also utilising the latest modern methods of construction. An example really of an amazing project that we were involved in recently at the Claridge's Hotel that was almost completely prefabricated. Prefabrication has really been a hot topic in the AEC industry for quite a while now, more so with the start of 2020 and the pandemic, when sites were either closed completely or reduced to work, forced to work with a reduced workforce. It really brought the concept of prefabrication to the table as an improved and efficient and sustainable workflow in these modern times. With the current uncertainty of the markets, inflation driving the cost of materials and fuel, etc., the only certainty we can really rely on at the moment in time is that moving to an efficient prefabrication workflow, utilising the latest advances in digital construction technology, is a true and tested way of saving time and money on building sites, whilst driving efficiency and reducing wastage of time and resources. And obviously, there is a cost involved in moving towards this system in itself, in terms of both your setup, your plant equipment, manpower, and the design tools that you use, which kind of puts a lot of the smaller scale firms off the investment. But I really do think that they fail to look at the bigger picture. Whenever complex work is removed from a building site to a controlled factory setting, its cost to the company decreases significantly, through raised efficiencies, tighter controls on quality and wastage, less impact on the environment with less material deliveries, etc. And more importantly, a higher safety standard and less risk for the workers in the factory against the site. But I do understand that it is hard to make that leap of faith, and it's not as simple as it can be sometimes portrayed in forums such as this. Here at Kane, when we began to fabricate items, it was on a very small scale, such as individual plant skids for pump sets or rooftop frameworks for supporting plant and kit. Back then, most of our sites were local in Northern Ireland, and initially all of these things were kind of built in situ on site. The frames and the skids were fabricated directly in the plant room that they would reside in. But as we grew larger and our project switched to the London market, the distance and the Irish Sea in between us made it much more difficult to manage all of these activities on site. Standards were slipping and problems on site caused a lot of loss of time and money. So we made the decision to open a workshop in our head office, produce the frames and rigs at home, and then ship them across to be assembled on site. Over time, as we developed the tools and the skills to produce these items, the scale of the items themselves also grew alongside it, to the point where no assembly was really being done on site. The entire rig was finished in the warehouse and shipped to be installed directly where required. Working in a factory environment allows much tighter controls on the quality, ensuring that everything is properly tested and signed off, and most importantly, documented prior to them leaving the factory, so that we have a paper trail to follow should there be any problems on site, making it much easier to track issues and find the origins of problems. In 2017, we moved to new premises in Banbridge, complete with a large warehouse and production facility with overhead cranes. And at that stage, we had firmly established ourselves as a prefabrication oriented contractor. And we were approached to consider the Claridge's Hotel Iceberg Basement project, a project that, in my opinion, could not have been done without using prefabrication and the modern methods of construction tools, due to the scale and the complexity of the installation, the logistics involved, and the time scale that we were afforded. The scope of the works was that the hotel had been undermined and a 5-story basement had been constructed below the hotel whilst it remained open and trading. The level B5 contains the wet plant room, and to give you an idea of the scale, each floor is approximately 100 metres long and 30 metres wide. And B5 contained all of the heat generating plant rooms, as well as all of the cooling plants and the large CHPs, and quite a few different pump sets to serve all the hotel. Level B4 contained the air handling unit plant room, and there was 27 large air handling units required there to connect to the existing network of ductwork serving the hotel above. The levels above were a mixture of stores and offices, and level B1 is a luxury spa and swimming pool. And all of this had to be installed using a 3.5 metre square access shaft at one corner, with very, very restricted access from the rear of the hotel. The project forced us to review nearly every process that we had in place at the time, from design to production and logistics and operations. We really needed to put ourselves right up to the crest of the technological wave and ensure that we were working as efficiently as possible to be able to deliver for our client, the Mayborn Group. As we did not have the luxury of accessing the site whenever we wanted to review proposed layouts or look at the site, we knew that we had to produce a highly accurate as-built structural model to ensure that everything that we were prefabricating would arrive and fit exactly as planned with no issues. So we went into the site and we did a full laser point cloud scan of the entire basement, all 5 floors, including the access shaft, and then we commissioned a digital twin to be produced from the data. This completely removed building tolerance from the equation, which for us was revolutionary at the time, as it always was really the missing link in the prefabrication process, the uncertainty of whether or not an item would actually fit in a place based on manual measurements of areas. And it gave us total confidence to work completely remotely in the early design phases. The cost of the point cloud scan model could have been similar cost to sending engineers backwards and forwards to site a few times, but the value of that digital twin was a magnitude more. So our 3D authoring tool, Revit, was the next step then. We basically took it totally apart, we analysed it and we upgraded it to allow us to be able to produce LOD 400 fabrication grade modelling directly within the federated model, where previously and traditionally we had referred to AutoCAD MEP to detail up all the fabrication grade shop drawings. And by doing that, it really left massive holes in our federated model, and it never really seemed to come back together again because it was in two separate systems. The goal really was to produce a full one-to-one simulation of the design plant spaces. We developed many custom families for everything. They were not available from the vendors. So we went down to model all of the fixtures, fittings, clips, hangers, steelwork supports. What that also did, it allowed us digital quantification then from the models. We were able to develop all of the high-level modules and rigs into assemblies, so that everyone involved from design to operations could see exactly what was being designed and prefabricated and knew exactly what was going to be arriving at the site. The next step then was really to bring in a VR technology that was new at the time. It allowed us then to review everything that we were designing at one-to-one scale from the inside out across multiple offices based across the UK and Ireland. And with the site itself, all the operatives on site had availability to look at this system. This ensured that all the layouts were fully road tested and reviewed prior to the final sign-off prior to manufacture, leaving absolutely nothing to chance. It also allowed us to run VR simulations with the site operatives, showing them the complex build sequence in steps, really a dry run of the installation, so that when the actual day arrived, everyone involved knew the drill as they'd already rehearsed it. So after all the accuracy in the planning and the production, we knew that we couldn't bring all these items to site and have it fall at the final hurdle, with the final step of manual measurement and installations, as we were under quite a heavy timeline and installation sequence due to having absolutely no storage on site. The solution was to develop a bespoke in-house precision laser setting out system from Leica that we took from the civil engineering world, and we molded it to work for us in the MEP space. This allowed predefined positions for structural fittings for the high-level modules to be set out in the 3D model using the as-built digital twin, and then we could translate these via the cloud to set out to sub-millimeter accuracy using the Leica Icon Total Station. The fixing points were marked, drilled, resin anchors set with the drop rods, and then once cured, they were load tested and signed off, ready in preparation for the modules to arrive. Once they arrived, they were hoisted into position, connected together with its neighbour, and on to the next one. So at the time, these digital construction tools that we developed and the systems were absolutely revolutionary, and we sought to push them out into all the projects that we were involved in, which we successfully implemented in 2021. We carefully consider each project at the outset, and where applicable, we engage with the main contractor and the end client and seek to utilise as much prefabrication as possible for corridor laterals for pipework and tray, complex M&E risers, and apartment utility pods as an example. It has resulted in a massive uplift in output on site for both ourselves and all the other trades involved in the site, a massive reduction in rework and wastage, and has resulted in a complete shift in the build sequence for us, where we are now on a floor doing all the high-level first fixings, trying to get about 65 to 70% of all of our systems installed at the first visit to the site, right before there's even any walls in the certainty that we are avoiding any clashes as it's digitally set against the digital twin of the structure. It also reduces the crossover of trades, where normally our engineers and the dry liners, for example, would be tripping over each other and getting in each other's way. Now we get a clean run at an open floor, complete as much of our installation as possible as we can, and then we leave the floor and the dry liners have full uncompromised access to complete their works. So it really benefits all the trades on the site and not just ourselves. We also utilise the point cloud scan technology for as-built verification, so that our model can be compared to the real world installation and adjusted for any site changes that may have occurred. This has greatly improved the efficiency in this exercise, as we had previously used hand marked up drawings and 2D photographs, which didn't always give our technicians all the information that they needed to correct the model. Now we can import the point cloud directly into Revit and see the actual site against our model, and the items can be aligned with extreme accuracy at a magnitude times faster than the traditional methods. We've adopted a range of digital workflows across the entire company, from design to production, operations to aftercare, with efficiency being the main global driving factor. Thanks very much.
Brilliant, thank you so much. That was another great presentation, such great practical examples, and we've already got plenty of questions coming in. So just a reminder to our audience, please do send those through as they occur to you, and we'll try and cover off as many of them as we can in the Q&A session. Before we get to that though, I'm going to hand over to Matt, who's our final presenter for this morning.
Thanks, Jordan. Just checking that that presentation's up on screen now.
Perfect.
Lovely, thank you. So yeah, just following in on that, our approach is slightly different. We're a full turnkey volumetric contractor, and so in sort of thinking about today, that what would perhaps be helpful is to try and share some real life examples of programs that I think are working, where to the industry strategy and the goals that were set in there, real tangible benefits are being delivered. It'd be helpful to unpack probably more the conditions that create that success, and maybe to point to some of the areas where other projects and other programs are not quite hitting that level of performance. Because I think we can all sit here, myself as a great advocate of the offsite industry, clearly. There are definitely areas where things aren't working and where improvements are required. So hopefully I'll be able to point to some of those as we go through and offer some views on how delivery of programs using more prefabrication and offsite technology can actually come about. So just looking, I'm going to use two programs. So one is the Department for Education's MMC Schools program, and another is the Defence Infrastructure Organisation's NetCap Transit Accommodation program. And two similar programs in as much as they have been shaped into programs, but slightly different approaches. So with the DFE, they have a very clear reference design. They use an output and performance specification. And what that enables industry to do is basically to develop a standardized approach that allows mass customization to really drive down not just the construction program. I mean, everyone gets very fixated with offsite prefabrication, that the real benefit is in offsite. I actually have a slightly different view. There are significant benefits that come there, but with the right early engagement, you can really squeeze down the front end of the design process, make sure that planning is in quicker, make sure that coordinated designs happen earlier and projects can be released more quickly. And I think that's as much the opportunity, and that's certainly been the case in the MMC Schools program. The NetCap approach with the DIO, they similarly set up an approach that looked at early engagement. They used a prototype, and then from that prototype sought to drive continuous improvements and engage with the supply chain to understand where opportunities really were. And the nature of this program is providing new transit accommodation for the Army, looking to reduce the carbon footprint of the Army's estate at the same time as improving the lived experience for the soldier. And given that focus, I think one of the things that stood out to me here about this program was the DIO and the MOD's openness to be challenged around some of the way that things have traditionally been done, particularly viewing life through a carbon lens. So on both of those programs, we're seeing significantly improved programs, as I say, both pre-contracts and on the construction works themselves. Huge inroads into the carbon agenda. So both of these programs are delivering buildings now which are operationally net zero. And whilst, and I'll kind of come on to the cost in just a second, but whilst construction costs I wouldn't say in headline terms is delivering 33% reduction as part of the industry goals. What we are really seeing is that program approach and the offsite approach is really driving great improvements in terms of the quality of the products and the performance of those buildings, which in turn has a significant benefit in the whole life cost of those buildings. So certainly for these programs, I would say they're absolutely achieving the goals of 50% reduction in time and in carbon emissions. And in cost, I think the benefit is coming in a slightly different area, more of that whole life cost than necessarily the capital cost itself. Now, I've indicated some of the conditions which I think are key there. So that early involvement, that thinking in program terms, and that being open to challenge the way that things have traditionally been done for good reason. And I think that's created the right environment here to deliver those benefits. I can point to a number of other programs, perhaps, or not programs, more projects, where there's an assumption or a desire perhaps to explore the benefits of prefabrication and offsite construction without perhaps setting that approach up for success. So perhaps designing things traditionally and then coming to the market and saying, okay, what can the offsite market, prefabrication, what can that do for us? And that's perhaps not the best way of getting the best out of the market there. And therefore, we do see projects like that are failing to achieve some of the industry goals. I'll come back to that a little bit later on. So just you've seen one approach in terms of the services and the coordination of that, which an inspiring case study here. Just to give everybody the same view here, we use category 1 in the offsite definitions, 3D steel volumetric production process, and we seek to line and level our buildings in the factory, complete as much of the works as we can. Here you can see some packaged plant rooms with the air source heat pumps ready to go, and I'll come back to why that's important in just a second. But we also, what we found is the best way of helping clients and customers to get the best out of the approach is really to think of our business as an integrated platform. And Ben at the outset highlighted the work by Bryden Wood, and I can only kind of reinforce from our perspective the importance of design and controlling the design for that approach to offsite construction and manufacturing. I'm going to come back to that in a second, because I'm actually going to start at the other side of this slide over here, which is that our view is that if we're really going to attack the 49p of every pound that the government thinks gets wasted in construction, and there was a report that was done a number of years ago now, but it basically said that for every pound that's spent, 49p goes on waste, inefficiency, redesign, error, risk on risk, overheads on overheads, is that you actually need to move to a vertically integrated approach where as a business, we take on, we have our own factory, we take on our own joiners, we have our own designers, and to really join the industry up in our own organization, we've really felt that's where some of the benefits, some of those cost and time savings actually come from. Why that's so important is that where we don't have in-house capabilities, we partner with organizations who bring a real understanding of how their components work, how they can be built up into sub-assemblies, and how that can be integrated into design. And that brings you back to the first base here, where having a true understanding of the requirements, having a true understanding of what the market is capable of, and having an integrated approach to the way that that is used in design and used to set the program up is absolutely critical. And taking the DFE's program again, what we've been able to do off the back of that is develop our own system families, our own, we call it our Red Book, which is all of our standard details, how they come together into, the components come together into assemblies and sub-assemblies. And through that, we're able to almost turn the design process around the other way. Instead of focusing on necessarily the concept and the concept drawings, asking our designers who work with us in that stage to actually configure the design around that approach. We then use technology, and because taking the DFE again, the DFE start at stage 1 and they look for a full turnkey approach, we're actually able to deploy the technology in the way that it's intended to be used. So we have control of the common data environment at the outset. The standards are set, and that enables us to leverage the full value of clash detection, of further downstream quality assurance approaches using technologies like OpenSpace. And that whole approach is what we call the integrated program. But again, focusing on what's required to really get the best out of our industry, it is all about controlling the design, leveraging the technology in the way that it's meant to be used, not trying to force it into existing business models or the existing way that the industry slices and dices the way that things are done, because that's part of the problem. And then getting as much knowledge from the supply side as possible fed back into the design. Now, from that comes the ability to deliver extremely high levels of pre-manufactured value. Here is a recently completed school called Abbey Farm down in Swindon, whereas you can see, well, actually what you can see here is you can see the ground floor and the first floor in the same factory, just about to be split back into its modules for transportation to site. So with this level of pre-manufactured value, which only comes from being able to coordinate and control the design using the technology, as I've said before, what we're able to do is to turn the construction element into a process and drive more of a production mentality on site. And it was interesting, it was mentioned a little bit earlier by one of the other speakers, but we have a similar view. The minute we step on site is the minute we've lost an opportunity to drive efficiency, because you cannot control the environment, you can't always control those elements that are going on around you. So driving that for that pre-manufactured value is critical. So a little bit of a deeper dive into one of those programs, the NetCap program. Here is a basic outline. What we're providing is an improved lived experience for those soldiers who are training. DREAM excellent. The requirement was to deliver net zero in operation, and that program is now getting up towards 100 buildings in the last 2 years. Now, what's interesting about that is that here's just a couple of images of the building going in. Each one of the buildings goes in 1 day, and usually 3 to 4 weeks to close out the building after that. But in approaching the program as a program and thinking about what improvements can be made, all of those buildings to you or I will pretty much look the same. But in actual fact, every single one of them has had an upgrade in some way, shape or form. Some of those are about upgrades to improve efficiency. But here I just thought I'd pull out that what comes from that with those efficiencies is the ability to be able to invest in better standards, improvements that drive better operational carbon performance, 6 improvements that reduce the embodied carbon, 8 that drove improvements in the building function, so how the end user was actually going to use the building, and then a further 9 that were all about the building specification, and those have been incorporated into the cost of delivery. So what we're seeing is the ability to get a better product quicker, and within the affordability envelope. So driving that continuous improvement, and we see that in the energy performance, and that comes, I mentioned before that some of the details of the buildings, whether it be about how some of the junctions were put together, they drive an improvement in the air tightness, always being fed back, and we see that continuous improvement. Similarly with U values, as we've looked at how things are done, and that has an impact on the operational carbon performance. And I spoke earlier about some of the improvement opportunities, but in challenging some of the existing specifications from a carbon perspective, we realized cost savings, and instead of handing those cost savings back, we're able to invest in the product, so perhaps putting more PVs on, which help drive a better operational carbon performance. So here you see the ability to harness that sort of value engineering and actually put that back into the product and drive a better outcome for the customer. Similar story on the embodied carbon, where because we're looking at those high levels of pre-manufactured value, using the standard details reduces the amount of waste that's required, because we can order the exact quantities. We know what works, what doesn't work. We can engage in the bulk ordering. All of it drives more work offsite in better controlled conditions using materials that are ordered and fit for the job, which reduces the amount of transportation, it reduces the amount of workers on site, it reduces the amount of time on site, the diesel that's used in sites, the generators, the skips, the amount of waste that's used. And actually doing some measurement on that with our waste management providers, our energy management providers, when we were baselining our own carbon performance, showing significant improvements on traditional construction, so having a real benefit here. And here's where I see one of the true values of that platform thinking that Ben mentioned before, that when you think about things in terms of spaces, and you think about standard components and sub-assemblies, and you get your head into the fact that if you can't see it, then standardize it, and if you can see it, find a way of mass customizing it, then there's lots of product development that can come from that. And this is all driven off the same platform, but whether we're looking at single story, dormitory style, double story, single style, en suites, more of a single living accommodation type product, they can all be driven off the same platform, which drives efficiency in the design and again reduces the front end design process and time associated with that. Because we're dealing with standard components and standard assemblies, importantly here, we can actually test the complete construction. And here an example of a recent fire test on the floor and ceiling details that was done in conjunction with the BRE. Now that quality and safety runs beyond just the building safety. When we have that all those standard details, I mentioned our red book before, it means that we can develop standard operating procedures. And here there's a couple that are around the fire ceiling. So this is actually communicating to the people who really matter, the people who are putting buildings together day in, day out, exactly what the expectations are, what good looks like, what won't be accepted. And we can combine that, as you can see here, with clarity on the safe way of actually completing those works. So these drive a much higher. We always talk about, a controlled environment in offsite manufacture. Here's a very practical example of what we mean by that. We have a repeatable approach that can be turned into a process. We can turn that process into a proper training. Again, Ben mentioned earlier the impact of labor. Completely understand the point that he's making. And in using an approach like this, what we're able to do is to train more people to undertake more tasks to a higher and more consistent approach, and to do that more safely, and that has fantastic benefits, as I'm sure you'll understand. So just the last area I was going to focus on, in terms of really, the question that was out there in the trailer for this event was, what have we got to do to scale the approach here? Because yes, I can point to examples that where things are working, but with 2025 looming, I think it's fair to say that not enough of those examples are being seen across construction. We all need to do more to achieve that. So my key messages would be, look, we have to embrace platform thinking. It doesn't mean that we end up with buildings that look the same, because that mass customization, we can have what we like. The building can look what it likes, but if we come from a common understanding of the spaces and how they work, and the components that come together, and we can standardize those, we can get much greater efficiency. That program thinking is critical. I've been asked to speak to a number of private developers, and they say, how can we get the best out of the supply market? I said, well, actually, I think you need to engage in a slightly different way, less hands-off, more hands-on. Think of it as a program. Maybe think about, how you are going to set those platforms up if you have a significant volume of work. Embrace that mass customization, and definitely what we've seen the benefit of on the two programs that I've spoken about is that early engagement, where there is often a concern that you might be backing yourself into a corner or down a particular system. If you're embracing platform thinking, that really isn't the case, but it is so valuable to have direct access to the people who put the things together, the people who design the components that go in there, to truly understand their performance, to truly understand how they can be made to work, and to truly understand where the efficiencies are, and to feed that in to the design, which is key to get control of at the front end as well. So those would be my 4 areas I think that could really help other areas of the industry to really scale and embrace what's going on. Thank you.
Brilliant. Thanks so much, Matt. That's another great presentation. I think we can all say we've been lucky to have 3 great ones so far. And I'm looking forward to getting into some of the questions because we have plenty of them coming in. But firstly, just a quick one from me is that something that you've all sort of touched on is like the benefits and the importance of making sure that this sort of prefabrication MMC approach is engaged right from the start of a project throughout the supply chain. A 2-part question really. A, is there a mature enough supply chain at all stages at this stage for that to be scalable? And B, what are some of the challenges to having that like early engagement, early in the design process? Matt, maybe if we go first to you, then Gary, and then if Ben, you have any thoughts, that'd be great as well.
Yeah, I'll go with the second part of your question first, in that I think our industry has done things in one particular way consistently for quite a long period of time now, and that is that we keep the client's business over here and the delivery end of things over there, and we don't tend to try and mix those 2 things because of concerns, and some of them valid, around risk. I think the biggest challenge that we have is in kind of breaking down that mindset and saying, it's the old adage, isn't it, that if we carry on carrying on, we're going to get the same results, and therefore we need to be prepared to adopt a different model for the right reasons. So I think that last point is really key. It needs to be for the right reasons, and prefabrication approaches may not be the right thing for your project, so be clear about why you're using them. I guess I see too often people who come and say, oh, prefabrication's the be all and end all, is the buzzword at the moment. Here's our project. What can we do with it, without any real thought about what they're trying to achieve? And if you can get everybody around the table at the start to be clear on what the outcomes everyone's striving for, from a customer's perspective, then I think you're creating the conditions for success. Is there enough maturity, was the other bit of your question, in the market? Well, I think, look, we've seen a number of businesses that have gone over as they've sought to develop that. These things happen, right? Some people who are out there being the pioneers, can run into trouble around that. But I think what we have seen is a steady increase and a steady growth in the supply chain and their maturity. And we continue to see that. And again, I think it's incumbent on everybody who's involved in the process, clients or professionals, to actually understand the market they're dealing with and find the right way of engaging with that market, because some of the reasons for those failures are actually people have engaged in the wrong way. So yeah, there's a job of work to do there, but I think again it just comes to that shift in mindset. Brilliant.
Gary, obviously you mentioned that for parts of what you were doing, it was to start off with in that case study, it was very first time it happened. It was all new territory, but are you seeing that sort of shift the more that you implement it on various projects and the benefits across the supply chain?
Yeah, I mean, we've always kind of been leaders in our field of what we were doing. There wasn't too many other MEP contractors producing the level of detail of models and processes that we have in place. But I think, as time is progressing, the entire industry is obviously moving towards, that goal. There is issues for us in the MEP space and for the supply chain, for example. A lot of the manufacturers and the people that we buy our stuff off don't have any detailed 3D data for us, so it becomes incumbent on us then to take the responsibility of that, to model the exact items that we require and make sure that is correct. And then there's a data part of it as well. So quite a lot of the projects that we're getting involved in, there's a BIM level 2 requirement where there's a COBie data. So at the moment, a lot of the responsibility falls on us for the delivery, whereas it really should pass back down the chain to the people that are making the objects and the items that we're proposing to give. And it is slowly moving in the right direction. I know certainly 20 years ago when I started doing design, it was all 2D polylines and thought of drawing a building in 3D was space age stuff, you know, it really was. And the ability that we have now, the tools are almost accelerating faster than the people behind it. I know certainly that we're seeing a shortage in skills of people that are able to actually coordinate complex M&E systems. We're reaching out to the education industry, and we're talking to the universities and the colleges here in Northern Ireland, and we're saying to them that, you know, the people who are learning to design M&E are only learning the theoretical side of it, you know, the pipe sizing and duct sizing. There's nowhere where you can actually sit and have a course of how to physically coordinate very, very complex M&E systems in very, very tight spaces. So I think there has to be a bit of a shift in a lot of places. There's no one area that'll push it to a conclusion. It's the technology, it's the people, it's the supply chain. Everyone involved in the AEC has to kind of move towards that. And early engagement is also a key factor. You know, we get involved in projects maybe at REBA stage 4, and there's been quite a lot of work that's been done in REBA stage 3 coordinating models that a lot of the times, you know, it ticks the box for the consultant involved because he's produced his layouts, he's produced all of his tender documents, but consultants always over-egg models, and you know, because they know people are going to be pricing from their models, they don't want to give a nice streamlined model for people to price on and then turn up to the site, and it takes twice as much material, twice as much time. So I think the whole process of REBA stage 1 to 7 needs looked at. You know, if we get early engagement and we come in much earlier in the process, it allows us to actually concentrate on the coordination at the same time that we're developing the design. It pulls all of the stages forward, and then coupling that with the modern methods of construction, like the digital setting out, we can slide, you know, all the time involved much forward, and try and look at the efficiency of the entire process, not just individual people's processes. We really need to look at, you know, when a client brings someone on, there's not real much point paying a consultant a vast amount of money to coordinate a model that ends up getting, you know, stays on the CDA and is never seen again. Once people like us come on board, we produce our own model, and all of the time and effort and money that went into that original model is wasted. So I think there's a lot of considerations in all the moving parts of it. You know, there's no real answer for one.
No, absolutely. Ben, did you have anything that you wanted to add on this one?
A couple of quick things. The first thing is that, you know, the traditional construction industry famously has this massively fractured, massively huge supply chain. Supply chains vary from job to job to job. I think it is absolutely inevitable as we head towards more manufacturing-based process, that supply chain relationships will shrink and will become much more stable, and with all the benefits that can offer, much more stable and smaller. I think it's just inevitable, and we've seen that if you look at other industries. You know, if you look at the automotive industry or something like that, they have very established supply chain agreements that remain pretty constant. So I think that's something. Another thing, just picking up on what somebody else said, I think this concept that for the designer, for the architect and designer, that we need to change the way that we work, it absolutely does not mean a lessening in design standards. You know, if I think about a kettle, it can be, you know, either a beautiful kettle or something that's functional and just does the job. You know, but it requires, you know, it's this Brian Wood idea of designing for manufacture and assembly. You know, it's a different way of thinking about the way that you do your job.
No, absolutely. We've had quite a few questions come in around the carbon agenda, which is something that you actually all touched on, which is great to be hearing, particularly topical at the moment, which is what we all need. But we've had quite a few questions around the impacts on both whole life carbon and the impacts on carbon and delivery throughout the supply chain by adopting some of these principles. Does anyone, essentially people just asking you guys to expand on that a little bit, if anybody wouldn't mind, that would be, I think, much appreciated by the audience, because I have quite a few questions on it.
Yeah, so maybe I'll kick that off. I shared in my presentation an example of the impact of the construction phase carbon, embodied carbon. That's obviously only one small part of the overall life cycle. Certainly looking at the product elements, the front end elements, in adopting things like PAS 2080, which is an approach where basically giving yourself a target and then forcing yourself to improve at every single stage of the design process. Again, the program approach means that you can reset that target and reset that target and improve and improve and improve. It drives that thought process of continuous learning. So we're certainly seeing the embodied carbon of the product itself going down. I spoke about the operational side of things. In terms of the reuse, we're constantly looking at how some of those, the relative merits of some of those sub-assemblies, and technology is moving very, very quickly. So what we're seeing is what might be the right solution for the next 3 or 4 buildings. Actually, when new products come online, may not be the right solution, because there might be another product out there. And certainly there are more suppliers now who are focusing on products that can be designed for reuse, and that goes all the way through the supply chain, all the way down into steel. Actually, we're looking at increased recycled content of the steel itself. So we're certainly, that program approach we're seeing as being beneficial in constantly improving what we're doing.
Brill, Gary, did you have anything that you wanted to come to on that point?
Well, for us, when we look at sustainability, logistics really was the biggest thing for us. Our head office is in Northern Ireland, and all of our work is in the London market. So, when we first started working in London, it was kind of haphazard. There was materials getting delivered to 5, 6, 7 different sites. There was quite a big impact on just the day-to-day activities of the company in moving people and backwards and forwards and moving things. So we really started to look at processes and how we could reduce our own carbon footprint as a company. So we invested heavily in technology that would try and remove the need for people to physically get on the plane and fly to London to look at the site. So we looked at, obviously there's communications technologies like Teams and Zoom, where we're able to do meetings remotely rather than in person. And then we also looked at other technologies like HoloBuilder, where we could have operatives taking panoramic photographs all around the site, so the QSs could review the site from their desk at home rather than having to go across, which is great for the carbon. It's great for the individual as well, because it reduces the time spent away from home and family. And then when we started really getting into the prefabrication process, we realized that it was a lot carbon better, that we held a stock of kit in our warehouse and had it delivered in far less amounts of deliveries. And then whenever we were able to build the items and put them all together, we fill the lorries that go across to London are literally filled from front to back to make sure that every square inch of that delivery space is used. So we don't really get into the carbon of the running of the buildings. Obviously, we're just an M&E contractor, but certainly sustainability is very, very important to us as a company. And as Matt says, we're continually reviewing that every year. We're analysing where our waste goes, how far is that going to, is it going to landfill at the far end of the country, or is it going to one local? We're looking at technologies to be able to track material deliveries and wastage and stuff like that. And I think that's it's incumbent on every company to try and be as as frugal with their carbon footprint as possible.
Bro, Ben, did you have anything that you wanted to add to that one?
Not particularly.
No, that's cool, because we're about to run out of time, which I'm very conscious of, because I keep asking questions. So what I was going to ask each of you do, I'm very conscious that we've covered a lot of ground today. As our audience has been telling me, they've got questions about every part of every presentation. So I was going to ask if each of you wouldn't mind just sort of giving 2 big takeaways for our audience, so they're living with the big things right at the top of mind to consider post. We could go maybe in speaker order. So Ben, if you wouldn't mind kicking us off.
So I would just say, grasping this idea of designing for manufacture and an assembly is such a key one for me. And I guess the other thing is to say, look, let's really, as an industry, let's grasp this and make those relationships between our company and other companies that are required to make, let's get those closer relationships.
Perfect. Gary?
Well, I think really for me, collaboration is key. There's no real point any one individual company or person in the process working to this level of detail if everyone else in the project reverts to the old way of doing it. So, early engagement and early planning is absolutely key to this process working for everyone involved. And then I think really the second takeaway would be that, the people. It's very well setting a goal, the government set this goal, but how much of that is being rolled back into education and supporting the guys that are coming behind, the young people that are coming through. We need to make sure that we're supporting the young generation, that they have the correct knowledge and skills to be able to adapt to the changing landscape of construction.
Perfect. And last but not least, Matt?
Yeah, it completely reinforced the other two, but I would say, in addition to that, embrace the change. We have to get after the efficiencies that we're talking about for many different reasons, whether it be carbon, whether it be cost or time or safety, all valid reasons, but it does require a different mindset. So embrace that mindset, and I think don't do that blindly would be my second one. Understand the outcomes that you're looking for, and set your program up for success in a way that encourages the supply chain to give you the best of what they've got. Those would be my two.
Brilliant. I'd just love to say a huge thank you to all three of you for joining me today. It's been such a great conversation. I could keep asking you questions and the audience could, but I'm aware that I can't keep you here forever. I'd also just like to thank Trimble Viewpoint for making today possible. We really appreciate it. It's been a great session, so really appreciate that. Also, to our audience, thank you so much for being so engaged, sending through so many questions. To anyone's question we didn't get to, I'm sorry. But really appreciate you coming along, and please do feel free to rewatch it via the same link now or share it with any colleagues who you think would appreciate it. The final thing from me to our audience, when this session ends in a couple of seconds, there will be a survey that comes up. It literally will take you 20 seconds to fill in, and it's just to make sure that we're putting on the sessions on the topics covering the areas that you want to be hearing about the most. So if you wouldn't mind filling that in for us, it really would be much appreciated. So again, a big thanks to all our speakers. That's it from me. Goodbye.